Today I will be talking about magnetic biochar serves as adsorbents of catalysts for the removal of antibiotics from wastewater and review. The work is published in recent number of Journal of Environmental Management. The work is in the cooperation of Professor Juan Gawel from Sydney University with University under the leadership of Professor Han-Jin Yu, and these numerous antibiotics are being released into this subpharmacoxol that ciprofloxacin as the most dangerous due to the still action. Therefore, their utilization is a very needed case. And this team proposed using magnetic biochar to utilize and break these bonding and degradation possibilities. In here, the water is very polluted, and only 10% of population has clean water. The rest, including Europe mostly, besides Europe, and a very bad situation. Therefore, there is a very need due to antibiotics proliferation and preventing the antibiotic resistance to rise than in the case of municipal wastewater treatment. Impregnation pyrolysis is one of the most common methods preparing biochar, magnetic biochar. The method involves immersing raw biochar materials into solution containing metal ions, consumed through mixing fluid by drying and high temperature calcination. Under oxygen-limited conditions, the resulting product is washed and subsequently dried using ultra-pure water. Typically, the pre-impregnation process precedes pyrolysis, yet an inverse process exists where it's initially produced through pyrolysis. Subsequently, this biochar is immersed in a specific solution involving steps such as consistent temperature mixture, certification, drying, among others. The magnetic biochar is produced with correlation of specific area surface as the most important factors and advantage of other materials. They are mixed, subsequently immersed, certification, thus prepared, enhancing its absorption capacity in compared to unmodified biochar. For instance, at 310 centigrades, the surface area was 121, at 500 increased up to 209. So magnetic biochar, it can be used as utilization also in high temperature. In case of prepared was from discarded saccharides at 500, 600 and 700 Celsius, used to absorb tetracycline hydrochloride in wastewater. Results revealed a notable increase in absorption efficiency corresponding to the pyrolysis temperature, 35% at 500 degrees, at 58% at 600, and a significant enhancement to 93%. The hydrothermal method involves a process where biochar is combined with a solution containing magnetic precursors and subsequently subjected to mixing with in a temperature range, typically between 100 degrees and 300 degrees Celsius. Utilizing the hydrothermal method employing titanium oxybutyrate to produce biochar titanium oxide and magnetic biochar titanium oxide, which notably augmented the photodegradation process. Illustrated the activation sledge biochar using chloride zinc through the hydrothermal method and consequently enhancing its absorption performance concerning antibiotics. For 145 milligrams was twice that, for example, by titanium and for the cigarettes char. So by the biochar magnetic was significantly higher. Co-precipitation where process is uniformly placed and excessive use solution, and ball milling was used to switch to mixing and precursor material to get the surface area increased from 3 meters square to 194 after ball milling. This idea metal doping was used the iron oxide prepared by with sulfide of iron and demonstrated a powerful ability. It was concluded that cephalux removal by perchlorate only activated iron oxide usage, surpassing additionally displaced the reciprocating. In addition, the metal enhanced incorporation of non-metallic elements. The chitosan derived biochar significantly staggered the oxidation efficiency using free radical pathway. This is now compared to the non-free radical pathway during the activation of metal char, and those metamagnetic biochar demonstrate versatility, applicability across a wide range, bolstering resistance of inorganic ions interference and ensuring intermediate. In the study of iron doped copper doped was degradation using acid acidification and adding sulfate to make more suitable for smoothing and using. The acid modification increased additionally from 227 to 390. So we see several methods to increase. There also the trouble that there were nanoparticle loaded to see iron chloride, and this helped addition increase. So we have several methods. The increased surface make that absorption of antibiotics was impossible of many times. So the absorption is a positive ball absorption. There's the antibiotic, for example, tetracycline has been investigated mostly, and finally, this give the the use and municipal way in case of this method. Give removal chloride was 33, but this may make in case potassium give removal of 77. That magnetite was in case tetracyclate with using of ferroxide and additional absorption coconut calcium in 3 hours. So this was the chosen the iron oxide to this remove. The notably significant in absorption improved the catalysis, remove 87% of some that of cephalatics and 94% of tetracycline in the solution. Mixed biochar was effectively the absorption capacity it removed was 167 milligrams of per liter per of using of using the the level flux in antibiotic. So we see the big potential of this solution that increase the removal, increase the surface potential, and oxidant dosage was recovery. This recovery was also made, so conclusion in that can be then after using to recycle using sodium hydroxide and then return to make and suitable. This makes very promising because this shows the additional removal process, binding methods to antibiotics, and utilization and breaking degradation generates the utilization of toxic byproducts. This is addressing cost-illustrated issue with raw material further exploring, and this is the good idea, I think. And thank you very much for listening to me.